In this time, we will continue for the 8 modules, which is the approach to the worker. Here, we will introduce some definition for the worker as the following. The first one is representative worker. What is the representative worker? The representative worker is one whose skill and performance is the average of the group and who is not necessarily a qualified worker. This is the representative worker. An average qualified worker is one who has acquired the skill, knowledge, and other attributes to carry out the work in the hand to satisfactory standards of quantity and quality and safety. This is the average qualified worker. This is the medium worker between the unskilled and the skills. Standard performance is a base of working that can be maintained by the representative worker. This is the standard performance, which is maintained by the representative worker throughout an entire work shift without harmful effects on the worker health or physical well-being. The work shift is usually considered to be 8 hours. This is the work shift. That means for 480 minutes. Work day during which the worker is allowed periodic rest, break, and maybe experience other interruptions. The term normal performance. What is the difference between normal performance and between the standard performance? There is no difference. Normal performance is often used in place of standard performance. Basically, the two terms means the same things. Normal performance is 100 performance. Normal performance is 100 performance base while the worker is working. While the standard performance is 100 performance, but with the condition that periodic breaks are taken and other delay are likely to occur during the shift. They are the same, but in the standard performance, in the performance or standard performance, some delay or other breaks can be occurred during the day. Several benchmarks of standard performance have been developed over the years. The most popular is the following. For the benchmarks, the following is working. That means the standard. That means the standard. Some standards working at 3 miles per hour, which is 5 kilometers per hour on level flat ground. This is the benchmark, which is a standard. Some standards. This is for examples. Distribution of worker performance, which is the sketch or the axis flow. This is, we can represent it by the delay production. Worker performance is expressed in the term of daily output. Thus, for an output 100 pieces per day, that means the shift is 480 minutes at average performance by qualified worker. This is the standard times here. Directly standard times, we can determine it 480 minutes. This is the standard time, 480 minutes. This is the standard time, directly standard time per 100 units per 100 pieces, or units per 100 pieces. That means 4.8 minute per pieces, 400 minute per pieces. This is the standard time for the average for the qualified worker. This is the, for example, okay. Now here the higher production, daily higher production, here the lower daily production. The average of these, that means average worker, qualified worker, means 100 pieces per day. 100 pieces per day. Okay, here standard performance is commonly defined to a base that can be readily attained by the majority of representative workers. This is, we said about this point. Standard performance can be represented by representative workers. A typical policy to define standard performance so that qualified worker is able to work at a base that is 130% more standard performance. Thus, here, if we see here, this is the production daily. This is the production daily. This one, the daily production. This is for our higher production. This is the lower production. For the higher production, that means low. That means standard time is less. Here, standard time. Here, this is the standard time. This is the standard time. This is the very fast. That means standard time is low. This is very low. That means standard time is greater. Standard time is greater. That means when the standard time is low or lower, this leads to the higher production. This leads to higher production. Here, for the average performance of average qualified worker, the standard times we said 4.8 minutes per minutes per pieces. Okay. Now, if here this production or this standard time is 130%. 130%. That means what is the previous or the standard time before this state? What is the standard time before this state? The standard time before this state can be calculated as the following, because in this point the qualified or the performance is 130%. 130%. This point here, it is increasing. But what is the state at the previous state? What is the previous state of this performance? Okay, we can calculate this by the following. Here, if we multiply the standard time, here in the average worker by the performance of the worker in the current state. The previous state will be 6.24 minutes per pieces. This is the previous standard time. Then the current standard time, which is 4.8, is increasing by 130%. This is the performance is 130%. Okay, or the daily production rate of 77 pieces per day, 77 pieces per day. That means if we make here 6 minutes, if we inverse this number, this is the numerator, this is the numerator. If we make the denominator to become numerator, that means 1 pieces, per 6.24 minute. Here we can do day means 480 minute. We can cancel minute with minute. And 480 divided by this number here, that means equal 76.9 or 77 pieces per day. Standard method. The standard method is the procedure that has been determined to be the optimum method for the processing unit. The standard method satisfies that one best method principle. This is the standard method. We have to search for the best method for the processing. It is the procedure that is the safest, quickest, and most productive, at least stressful to the worker. This is the method or the best method for the processing. Safest, quickest, and most productive, and less stressful to the worker. The standard method should include the following details about how a task is performed, including procedure, action, and motion used by the worker. This is the best described by the listing the work elements that comprise the work cycles. The predetermined time system provides a natural means for doing this because they list the basic motions and comprise the procedure. For direct time study and standard data system, the procedure must be included in the statement of the standard method. Tools. What is the tools? Tools. This includes hand tools and portable power tools, fixtures, and gauges used in the procedure. Equipment includes machinery and safety equipment used to perform tasks. Workplace layout. How is the workplace arranged? This is some definition in the methods engineering. What are the location? This is the workplace layout. How is the workplace arranged in the best arrangement? What are the location of the parts, tools, etc. that will allow for the most efficient methods? Where do the work units enter and exit the workplace? What is the location of the enter and what is the exit of the product or production? And overhead layout sketch for a workplace is useful means of the documentation. Irregular work elements. What is this? Includes irregular work elements includes tasks that are not performed every work cycle. This is irregular work. Depending on a task, these elements may include changing tools as they wear out, changing tools when we change the tools, when they wear out, changing parts, containers as they becomes empty. This is also of full and any periodic maintenance of the equipment that the worker is required to perform. Working condition, what is it? Is the work performed outside or inside? What is the surrounding temperature, noise levels, and other conditions that might affect the work environment? Setup, what setup of the physical tools and equipment is required to perform a task? How much the time is allowed for this setup? This is the beginning of machinery. All of these factors should be throughout documented in written statements of the standard method. Standard input and output work units. Most tasks involves a process or action performed on the work unit. The state or conditions of the work unit is altered in some way by the task. The time required to accomplish the task is likely to depends on the conditions of the input work unit. Therefore, these conditions must be specified as completely as possible in the standard method statements. Similarly, the conditions of the output work unit must be specified also. Exactly what changes have been made in the work units as the results of the task performed in out. What is the final state of the completed work unit? Also, we have to concentrate for all these input and output work unit. Allowances and time standards. What is the allowances? Here we can make in all of the work measurements techniques, the normal time is adjusted by an allowances factor on the obtained the standard time. This we said about the normal time. Normal time is the observed time multiplied by the average average rating. This is the normal time. Then the standard time, we said also the standard time is normal times multiply allowances time, which is here we can say it, allowances time, that means extra time for the normal time. That means normal time plus normal time into allowances time percentage. The purpose of the allowance factor is to compensate for this lost time by providing a small increment of allowances time in each cycle. This ways, even with the times losses, the operator will be able to complete a day's work during the hours of the shift. That means the allowances can compensate the delay, the fatigue, and some waste time happened by the worker. Okay, here we can say the standard time here. If this is the normal time, common factor. This is the common factor here. We said here common factor here. We said here plus maybe normal time multiply allowances time due to personal time, due to fatigue, due to delay. This is the common factor here, and here plus 1 plus allowances time. Reason for lost time at work. Here, for the comparing between work related interruptions and non-work related interruptions. Here, machine breakdowns, waiting for materials or parts, receiving instruction from foremen, and taking to co-workers about work-related matters. Here, rest breaks for fatigue and cleaning up at the end of shift. And here is the non-work related interruptions. Personal needs restroom breaks, taking to co-workers about matters unrelated to work, lunch break and smoke break and beverage break also, and personal telephone call. How to allow for lost time? Two approach used by companies. Schedule rest breaks during shift and personal time fatigue delay allowances is added to the normal time. What is the personal time? What is the fatigue? What is the delay here? Personal time, restroom breaks, phone calls, water fountain and stops, and cigarettes breaks. This takes 5% typically. Fatigue rest allowances to overcome fatigues due to work related stress and conditions. This is also take 5% or some maybe more. Delays, machine breaks downs, foreman instructions. This is also takes 5%, which is totally 15%. Contingency allowances. What is the contingency? Here other types of allowances. Sometimes there is a contingency allowances, additional allowances due to the problems with the task. For example, raw material problems. Maybe the material, the problems in the material, it is not satisfactory for the instruction or for the another condition for the materials. That means it is not as in the specification. Policy allowances. These allowances are intended to cover special work situations that are usually associated with the wage incentive system. This is the policy allowances due to the wage incentives system. Training allowances for workers whose responsibility include teaching other new workers in their jobs. This is the training allowances for the foreman or for the person who is familiar for that machines or that workstation. Learning allowances for workers who are learning a new task or new employees who are just beginning to work. This is also allowances can be added to the allowances. Here contingency allowances, we can see here contingency allowances, material or parts, process and equipment. Measurements. I think this is the measurements for how can we measure the process, the temperature, the pressure. All this measurement is procedure in which a known quantity is compared to a known standard using accepted and consistent systems of units. The measurement provides, this is the numerical values of quantity of interest within certain limits of accuracy and precision. All measurement systems are based on 7 basic physical quantities. Number 1, length and mass, time, electrical current, temperature, luminous intensity and matter, and so on. Relative accuracy of time standards. We here relative accuracy for accuracy standard data system. Here we said about the standard time techniques for estimation, historical records, work sampling, and predetermined motion time system, direct time system, and standard data system. Here, for the measurement of these techniques, here estimation, here relative accuracy or precision. For the estimation, it is poor. For the historical records, it is between fair and poor. The very good accuracy for the measurement of standard data system. For the measurement of standard data system, this is the very good accuracy. Application of speed ratio and work measurement. The related term is application speed ratio. What is the application speed ratio? Which is the ratio of the time required to determine the time standard relative to the standard time itself. Then the ratio of the time required to determine the standard time itself relative to the standard time itself. Standard time required to determine the standard relative to the standard time itself. Then what is the standard time? How much or how long it takes to determine this standard time. If we make a ratio between the time required to determine the standard time and the standard time itself, this is the application speed of ratio. For example, an application speed ratio of 100 means 100. If the application speed ratio is 100, what does this mean? What does this mean? That it takes 100 minutes of analyzed time to determine 1 minute per pieces or 1 minute per units. This is what is the 100? Here the 100 is the time required to find or to calculate the standard time, and this is the standard time. Then the ratio is 100 over 1. 100 over 1. The predetermined motion time systems have a large range of application speed because of the variety of systems available, some of which are very accurate but very time consuming, while others are less accurate and takes less time. This is the predetermined motion time system. This is the very accurate. It takes long time. The application speed for the standard data system and historical records are relative fast, but this system required a sustainable investment of time to develop before they are operational. Work sampling is omitted from the chart because it requires an extended period of data collection before standard can be determined. Here, this chart, we see also the techniques of the standard time here, estimation, historical, and predetermined. Here, relative application speed for the speed. Here is the fast, this is the medium, this is the slow. This is, we can find the standard time by these techniques is very fast, and by predetermined motion time systems, we can find it by very slow and sometimes medium. Here problem, if we take a problem, the average observed time for the repetitive work cycle in a direct time study was, this is the observed time, was 3.27 minutes. The worker's performance was rated by the about 90%. The company uses a personal time fatigue delay allowances factor 30%. What is the standard time for this task? It is very easy. Standard time, here the normal time. First we have to calculate the normal time, which is the observed time multiplies the average time, average rate. Here average rate, average rating, here average rating. Then the standard time is the normal time addition to the normal time by the allowance time, or which is normal time multiplied by 1.130. Problem 2 also the same. Here For the observed time, we can see 3 observed time. We can see 3 observed time here. Multiply the average rating here the normal time, which is the observed time multiplied by the average rating. Here we can see 3 elements. This is the element 1, element 2, element 3. Here ABC company uses a standard data system to set standard data system. Here standard data system to set time standards. One of the time study analyzed listed the 3 work elements for new tasks that be performed on the shop, and then determine the normal time values by the normal time values. Here the normal time values, it is already obtained. Here it is already obtained, which is the observed time by the our time or multiply time or multiply average rating. The company uses personal fatigue delay allowances factor, which is 16%. Determine the standard time. It is very easy here. Problem 3, we can see here problem 3, determine the personal time fatigue. Here we determine the personal time. Here determine the personal fatigue, which is the allowances A, B. We need allowances A, B, F, D. This is the unknown. We need to calculate this factor, but uses computing time standards in the following situation. Second shift workers punch, and this is the second pinch, and at 3:30 p.m. and punch out at the 12. This is the during time midnight. They are provided 1/2 hour. They are provided 1/2 hour for sober at 6 p.m., which is not counted as part of the 8 or for the shift. For purpose of determining the allowances, here 30 minutes of break time, personal time, and fatigue 30 minutes are allowed each worker. In addition, the plant allows 30 minutes lost time due to the unavailable delay. And what should the personal fatigue delay allowances factor be? Here 30 minutes solution, 30 minutes breakdown plus 35 for loss, that means 65. Allowances factor APDF will be what? Will be first the effective time. First the effective time is here 480 minus 6 minus what? Minus 6, 65. Then the shift divided by this number minus 1. Here this is the personal fatigue delay allowances time. This problem also, you see these problems. Here the work shift at ABC company runs from 7:30 a.m. to 4:15 p.m., which with 45 minutes break for lunch from these times, or from between this period. That does not count as a part of work shift. Workers are not paid for this time. There is no any wage or salary for worker in this time. The company provides 212. The company provides 212. That means 24 minutes rest breaks during working. That means two times. Each is 12 minutes. That means 24 hours. Bedtime. This is the bedtime. One in the morning and 1 in the afternoon. 1 in the morning, and when this is the 12. 1 in the morning and the 12 in the afternoon. The company also allows 25 minutes per day for personal needs, bedtime, in addition work. Sampling study has shown that on average, an available daily in the plant results in 20 minutes lost time per worker per day. This is also bedtime. Determine the allowances for the personal fatigue delay factors for the following two management policies on allowances. Number A, the 212 breaks are both scheduled breaks that all workers take at the same times, and B, the 212 minutes breaks are included in the allowances factor, so the workers can take their breaks whenever they please. The solution will be as here the personal time is 25 and the delay time is 20. That means 45 minutes. 45 minutes. And there is also two breaks, each represent 12. That means the effective time or the total work time for 180 minus 45 minus 24. Thus, the allowance factor will be as here 45 divided by the effective time. That means 10 or 11%. Allowances time consists of two minutes rest breaks, 2 minutes, two 12 breaks, and 25 minutes for the personal time and 20 minutes for the delay time. That means if this is the includes, if this is the includes, which means is bed, which is mean bed for the worker, that means the total waste will be 69. That means here the same, the effective time is the same, and the allowances factor will be the new number, which is 69 divided by 411. Thank you.